Hi guys! So this is Sir Jack ulit. So ngayon mag-example tayo sa strain and deformation sa strength of materials. So yung problem, the force applied to the handle of the rigid lumber arm causes the arm to rotate clockwise through an angle of 3 degrees about pin A. Determine the average normal strain developed in the wire. Originally, the wire is unstretched. So as you can see dito sa problem, yung original niya drawing ito, tapos ito yung wire, tapos nag-apply force at point C. So yung length ng wire is 600 millimeters. So kung mapapansin nyo guys, yung distance ng AB at AD hindi magbabago. Na ang equal ng length ng AB is, using trigonometry, AB is 600 cosine 45 degrees or equal yan sa 424.264 millimeters. Then ang length ng AD is 600 sine 45 degrees millimeters equal, actually same lang no, yan yung value ng length ng AD and AB which is equal. Ngayon, nag-rotate down yung lever arm clockwise 3 degrees. So as you can see, this is 3 degrees na binaba niya clockwise papunta doon yung rotation ano. Ibig sabihin, yung total angle nito is 90 degrees na, from 90 tapos plus 3 degrees clockwise kaya naging 93. Ngayon, kung mapapansin nyo, yung wire humaba, pero yung length ng AD at AB, this B, same pa rin na equal yan sa 424.264 millimeters. So this is the new length of DC. Sabihin natin, this the new length of DC or DC prime. For example, DC prime yung new length. So para ma-solve natin yan, kung ang AD is 424 tapos ang AB is 424.264 millimeters, pwede natin makuha yung DC prime. Nang gagamitin natin is cosine law. So para makuha yan, so cosine law, DC prime squared is equal to AD squared plus AB squared minus 2 times AD, AB, then cosine 93 degrees. So, ganyan yung pag-cosine law, guys, no? Then, direct substitution lang, guys. So, yung DC prime is 615.5 millimeters. Ito yung new length ng DC or yung wire. Ngayon, yung tanong is the strain. Ang tanong, determine the average normal strain developed in the wire. So, para makuha natin yung average normal strain, yung average normal strain, yung symbol epsilon, equals yan sa deformation all over original length, or yung deformation, or that's the change in length, na equal yan sa, so this new length minus original length all over original length. So, yung new length is 615.5 millimeters minus yung original length na 600 millimeters all over yung original length ng wire ulit is 600 millimeters. So, yung value ng epsilon or the average normal strain is 0.0258 mm per mm. So, next problem tayo guys. Basahin ko ulit yung problem. The acrylic plastic rod is 200 millimeters long and 15 millimeters in diameter. If an actual load of 300 newtons is applied to it, determine the change in its length and the change in its diameter. So, ito yung problem. And may given na modulus of elasticity ng plastic equal sa 2.70 gigapascal at may Poisson's ratio na 0.4. Gagamitin natin yan mamaya. So, first, determine muna natin yung change in length or the deformation due to the actual load of 300 newtons. So, may formula tayo para sa change in length or para sa deformation na equal sa PL over AE. This is the change in length equal sa direct substitution lang guys, no? PL over AE. Ang P is the value of the force applied, yung actual load. L is the length of the material. A is the cross-sectional area. Then E is the modulus of elasticity. So, yung given force is 300 newtons times yung length 200 millimeters all over. Yung cross-sectional area niya, may given na diameter is 15 millimeters. So, ang area is pi over 4 d squared, 15 millimeters squared, times yung modulus of elasticity ng plastic is 2.7 gigapascal or 2,700 megapascal or 2,700 megapascal or newton per square millimeters. So, cancel yung mm squared, cancel lang newtons. So, yung value niya is 0.126 millimeters. Or, ito na yung change in length. Ngayon, para makuha natin yung change in diameter, gagamitin na natin yung Poisson's ratio na ang ibig sabihin ng Poisson's ratio equal siya sa negative the strain in lateral side all over the strain at longitudinal side. Or ito yung longer side. Ang longer side or itong longitudinal strain is equivalent yan sa the deformation all over original length. Na may given na tayo na nakuha natin yung deformation or the change in length na 0.126 mm, i-divide natin sa original length, yun na yung strain para sa yung longitudinal. So equal sa 0.126 mm all over original length na 200 mm. So equal siya sa divide 200 0.0000629 mm per mm. So, ito yung strain sa longer side. Ngayon, para makuha natin yung strain sa lateral, gagamitin natin itong strain para sa lateral para makuha yung change in diameter. So, i-substitute natin ito sa formula. Then, yung value ng Poisson's ratio is 0.4. So, direct substitution lang. So, strain in lateral equals strain in longitudinal times negative Poisson's ratio kasi may negative, no? So equal yan sa itong value times 0.4. So 0.000629 mm per mm times 0.4. So ito na yung strain at lateral. So yung times 0.4 negative 0.000215 mm per mm. Kung mapansin nyo, bakit negative? Kasi pag nag-apply tayo ng 300 newtons tapos tension siya. So, pag humaba itong plastic, kung mapansin nyo, yung diameter niya is lilit. Kaya yung strain at lateral is negative. So, dapat ang makuha natin na new diameter is smaller sa original. So, para makuha natin yung change in diameter, yung strain lateral equal yan sa change in diameter all over original diameter. So, para makuha yung change in diameter, the original diameter times strain lateral equal sa 15 millimeters times itong negative 0.0002515 0.0002515. Ngayon, yung change in length is equal to times 15 negative 0.00377 millimeters. So, ito na yung sagot para sa number 6. Para sa next problem, the load of 800 pounds is supported by the 4 stainless steel wires that are connected to the rigid members A, B, and DC. Determine the angle of tilt of each member after the load is applied. The members were originally horizontal and each wire has a cross-sectional area of 0.05 square inch. So, ito yung problem. So, first, solve muna natin yung lahat ng forces na dinadala ng mga cables or yung steel wires. So, first, kuha muna ako ng free body diagram. So, kunin ko muna to na AB na rigid member AB. Then, solve natin yung force AH and force BC. So, mag-summation of moments at summation of forces tayo. Summation of moment at A equals to 0 or equate natin yung clockwise sa counterclockwise moments. So, at moment at A, ang mag-create ng clockwise is 800 times 1 foot. 800 times 1 equals, yung mag-create ng counter is BC times 5 feet. So, BC times 5. So, BC is 160. Then, summation of forces vertical equals to 0. Lahat ng pataas equals lahat ng pababa. AH plus BC equals 800 pounds. So, yung AH is 800 pounds minus 160 pounds is 800 minus 160, 640 pounds. Then, kunin naman natin yung forces para sa DE and FC. So, kunin natin yung rigid member DC para sa free body diagram. This is DC. Then may force tayo dito na AH. Tapos ito, BC. So this is 640. This is the force FC. And may force dito tayo na DE. Then summation of moments ulit. Tapos summation of force vertical. So first, solve muna natin yung FC. So pwede tayo mag-moment at D. Summation of moments, point D equals 0. Or equate natin clockwise sa counter. Mag-create ang clockwise is 640 and 160. So 640 times yung moment arm. This is 2 feet. Tapos ito 5 feet. So 640 times 2 plus 160. Yung moment arm ng 160 is 7 equals, yung mag-create ng counter is FC times 7. So FC is 2,400 all over 7 pounds. Then solve natin yung force DE. Summation of forces vertical equals 0. DE plus FC equals 640 plus 160 or 800. So DE is 800 minus 24 all over 7. So 800 minus answer. This is 3,200 all over 7 pounds DE. Then right after masolve natin lahat ng forces na dinadala ng lahat ng steel wires, pwede na natin makuha yung deformation ng every steel wire or yung change in length nila. Para makuha natin yan, solve muna natin yung para sa AH, BC, tapos yung DE and FC. So solve yung para sa AH, deformation AH, PL over AE. Yung force niya is 640 pounds times yung length niya is 4.5 feet or multiply tayo ng 12 para maging inch all over yung area, yung times modulus of elasticity. Yung area gamitin natin is 0.05 square inch. Square inch to guys, no? Times yung modulus of elasticity, yung gagamitin natin is 29 million para sa modulus of elasticity para sa steel. So dapat sa ulo nyo yun guys, ha? So 29 times 10 raised to 6 pounds per square inch. Yan yung value ng modulus of elasticity ng steel pag naka-English. So cancel ang square inch, cancel ang pounds, then may iiwan is inch. 640 times 4.5 times 12. Solve naman natin yung para sa BC. So, para sa BC, PL over AE ulit. Yung force sa BC is 160 pounds times yung length niya, 4.5 times 12 para maging inch. Same ulit na area, 0.05 square inch. Same ulit na modulus of elasticity, which is 29 times 10 raised to 6 pounds per square inch. Inch is the deformation para sa BC. Next is the deformation para sa DE. Nang D is 3,200 over 7. Para sa DE, equal PL over AE ulit. Nang force is 3,200 all over 7 pounds times yung length niya is 4 feet times 12 para maging inch. Yun. 3,200 over 7 times 4. One, 5. Ganito yung deformation para sa DE. Para naman sa FC, yung force para sa FC is 2,400 over 7. Four times 12 per inch over 0.05 times 29 times 10 raised to 6 or 29 million. Yung deformation of FC is 0.011349. So, nakuha natin guys yung mga deformations ng individual steel wires. So, kinonvert ko muna sila sa feet kasi gagamitin natin yan para sa consistency ng units. So, dito sa baba, kung nakikita nyo, ito na yung nangyari nung nag-deform lahat ng wires. So, in-exaggerate ko lang guys yung mga deformations, no? So, ito yung para sa DE, ito yung para sa FC. Ito yung original length ng wire DE, 4 feet, pareho 4 feet yan, pantay. Then, yung AH and BC, pareho 4.5 original lengths. Then, ito yung deformation para sa AH. Then, dinagdag naman din natin dito para sa BC. Ngayon, yung tanong sa problem, determine the angle of tilt of each member. So, kung kukunin natin, for example, ito, mag-set ako ng angle, kukunin ko as theta, so solve natin yung theta, then ito, solve natin as alpha. So, para masolve yung theta, kukunin natin yung triangle. Ngayon, yung itong length na to, equal yan sa itong total length dito from yung hinaba dito, minus ito na yung length ng side niya. Para makuha yan, sabihin natin ito is Z. So, ang triangle na yan, kukunin ko as dito ko lang lagay. This is theta. Sabihin natin yung length na yon is Z. So, para makuha ang Z, this total length minus this total length. So, yun na yung z. No? So, ito 4 plus this minus 4 plus this. No? So, 4 plus ayun. So, ito yung value ng z. As you can see, cancel yung 4 feet. So, yung minus lang natin yung DE minus FC. So, yung DE, may value tayo nito, minus yung value ng deformation ng FC. So, hindi ko na guys sulatin yung value. So, automatic i-calculate na natin. So, yung DE 0.0012611 minus 0.0000949,792 long 0. Then, this is the value of Z. Naka-fit 0.000311308 feet. Then, para makuha natin yung angle theta, ito guys na length, di ba may original length dito guys na 7 feet? So, ito yung length. This is 7 feet. Para makuha ang theta, magagamit tayo ng tangent sa trigonometry, which is tangent equals to opposite over adjacent. So, Z all over 7. Tan theta is, so theta is arctan of 0.000. So, ang value ng theta is degrees. Ito yung angle of tilt ng member DC. So ngayon, nakuha natin yung angle theta para sa angle of tilt ng DC. Ngayon, yung angle alpha, ipapa-assignment ko na lang sa inyo. So try nyo i-solve guys yung alpha. Basta ganito yung guys yung behavior ng wires. Gamit lang kayo ng trigonometry to solve the angle alpha. Yun.